Hello guys, Mr. G here again, and now in this other video we're going to be looking at concentration of solution and maybe the composition of substance. Okay, so let's begin with the concentration and let's do it quickly. Let's just write down the definition of concentration. Now, by definition, molar concentration is the number of moles of solute per liter of solvent. Now, important, note that a liter is equivalent to a decimeter cubic. So 1 liter is equal to 1 decimeter cubic. That is important because sometimes we're going to work in liters and sometimes in decimeter cubic. And the other important conversion here is that 1 milliliter is equal to 1 centimeter cubic. Okay, so those are important things you need to know here. All right, so that is important unit we're going to be using now. If you see the formula, the definition, the definition is just the formula for concentration. The symbol for concentration is going to be C, and this is equal to number of mole. I'm telling you there, number of mole is equal to the number of mole per volume of solvent. So this here is the formula of concentration and is also the definition. C stands for molar concentration. Now note that the unit for concentration must be mole per decimeter cubic. So if it is not in decimeter cubic, the volume, it must be converted. Okay, and now from centimeter cubic to decimeter cubic, you must divide by 1,000. So this is volume, and it must be in decimeter cubic. It must be in decimeter cubic. Now, if we combine some formulas, remember now as well that the number of mole was mass divided by molar mass. If we rearrange this formula, we substitute in there, we get another formula that can help us to calculate concentration. And that one will be concentration is equal to mass divided by a molar mass multiplied by the volume. It's the same, it's just the playing with formulas. Okay, so this is a same formula, but one of them you have the number of mole and the other one is in base of the mass. So you can use either one indistintly. Okay, so it doesn't really matter. So now let's quickly have something very important to know. This is very important. If a large amount of solute is dissolved in a small quantity or amount of solvent, then the solution is going to be concentrated. So a concentrated solution is when you have a lot of solute in a small quantity of solvent. Okay, so that is what we call concentrated. Now we have also the definition of dilute, which is very, very important. And if a small amount of solute is dissolved in a large volume of solvent, then the solution is dilute. Okay, so those two definitions, small amount solute dissolved in a large volume of solvent, that is dilute. Those two definitions are important. You're going to be using them up until grade 12. So please do your best to record them. It is important and it's not so difficult. So let's see if we can look at one example to calculate concentration, and then we're going to be working with a composition of a substance. All right, so let's look at this example. This example says 130 grams of magnesium chloride, MgCl2. That is the formula for magnesium chloride. Please go back and watch the video that I make to write formulas of compounds. Is dissolved in 300 milliliters of water. Calculate the concentration of the solution. So before we carry on, let's see what we have. All right, we have that the mass of magnesium is equal to 100, magnesium chloride, no magnesium, magnesium chloride is equal to 130 grams. We know that the volume is of the liquid of the solvent is going to be equal to 300 milliliters. Now, we cannot work in milliliters. How do we convert from milliliters to liters? We have to work in liters or in decimeter cubic, which is the same. So to convert this one is going to be equal to 300 divided by 8,000. From milliliters to liters, you divide. This one will be equal to 0,3 decimeter cubics or liter cubics. So how we go on now? Now we need to calculate the molar mass of the sodium of magnesium chloride, not sodium, magnesium chloride. We need to calculate the molar mass. So also go back to watch a video related to calculating molar mass. So the molar mass of magnesium, okay guys, here we are with the periodic table. Now here you can see that magnesium, the molar mass of magnesium is 24 and the molar mass of chlorine is 35,5. So we have one magnesium, which is 24 plus 2 chlorines. So it's 2 times 35,5. Okay? And now this one will be equal to 95. All right? So this is 95 grams per mole. Now, if we go to the formula that we can use, we have the mass, we have the volume, we have the molar mass. So the most suitable formula to calculate concentration will be equal to mass divided by molar mass multiplied by the volume. The mass is given to 130. The molar mass we just calculated and was equal to 95. It is 95. And the volume, we know the volume, it is given to us, is the 300 milliliter converted to 0,3. 0,3. And so when we calculate this one, we have that the concentration will be 4,56 mole per cubic decimeter. I really hope you understand this question. It's not very difficult because we are going to go now to the next topic real fast, okay? The next topic is going to be the composition of substances. Now we're going to be talking about percentage composition, all right? So what is percentage composition? All right, so what is percentage composition? It is the mass of each atom present in a compound expressed as a percentage of the total mass of the compound. Now, this is the definition. In other words, is what percentage represent each atom when you have a specific compound. What is the percentage of each atom in a specific compound? And to calculate this one is like calculating any percentage, okay? Any percentage. So to calculate this one, we have percentage by mass, which is what we want to calculate, will be equal to the atomic mass, the mass of each atom individually, divided by the molecular mass, that is the mass of the whole molecule, multiplied by 100. That is more or less the formula. This is not the formula, it's not going to be giving you, it is a normal percentage calculation, okay? So saying that, we can look at one example quickly. Now this example say calculate the percentage that each element contribute to the overall mass of H2SO4. This is sulfuric acid. So we have H2SO4. All right. So the first we're going to do is we're going to break it into each respectively atoms. Okay. So we have H, we have S, we have O. However, we have 2 hydrogens, we have 1 sulfur, we have 4 oxygen. Okay, so now we are going to the periodic table. I show you already how to do it. I won't go there right now, but you can go to the periodic table and you are going to look for the atomic mass of each atom there. Hydrogen in this case will be 1, so it's 2 times 1, which is equal to 2 grams per mole. Okay, now the second one is sulfur. Now sulfur is going to be 1 because it's only 1 sulfur in the molecule times 32, which is the molar mass of sulfur. Okay, this is 32 grams per mole. And then it's for oxygen. Oxygen is 16. So you will get 64 grams per mole. So that is the first step to calculate the mass of each of the atom in that specific compound there. Then we're going to calculate the molecular mass of the compound, which in this case is quite easy because all we have to do is to add them. So you add them and you will get the molecular mass. In this case is 98 grams per mole. All right. So now we go into the formula of the percentage individually. So we have here hydrogen. I'm going to write hydrogen. Now hydrogen, the percentage of hydrogen will be equal to 2 divided by the total, which is 98, multiplied by 100, and that will give us 2%. Let's go to sulfur. Now sulfur, percentage of sulfur, you go to 32 divided by 98 multiplied by 100, and that will give us 32.7%. And we go to oxygen, and oxygen we have a percentage is equal to 64, you can see it there on top, divided by 98 multiplied by 100, and this one will be 65.2%. Okay, 65.3, not 2. 65.3%. And this is how you calculate the percentage. So in this compound, you can see that in this compound 2% belongs to hydrogen, sulfur represents a 32.7%, and oxygen represents a 65.3%. And note something important here. When you add all this, it must give you 100%. Be careful because we are calculating percentage, so it doesn't need to be exactly 100. It could be 99, something, 100 and something, because it's very close to 100 because of the rounding off. Okay, but it should be around 100. So that is the answer for this example of how to calculate the percentage composition. I hope it helped. I don't find it that difficult. It is quite easy. It's calculating percentage, and you know how to calculate percentage. Alright guys, so this is going to be all for now. Next time, if we have time for the test, we'll work with empirical formula. I don't know if will be time. I don't know if you guys would need that video. You can write a message. You can ask me. But thank you for watching. Good luck. Please thumb up, subscribe. Up until next time.